Welcome to Part 8, Functions. Functions in Python use the def or def keyword, as in you're defining a function. We will also talk a bit more about some useful methods for various Python objects, which will behave basically as functions you can call off of the object. Let's get started by hopping over to our editor. Alright, so remember that a function, formally, is a useful device that groups together a set of statements so that they can be run more than once. And it can also let us specify parameters that can serve as inputs to the function. But on a more fundamental level, they basically allow us to not have to repeatedly write the same code over and over and over again. So what we're going to do is start with the def keyword. And you can actually just hit enter here, def, and then you can have the name of your function. And Python uses camel case, snake case for function names, unlike JavaScript, which uses camel case. So if you want your function, you say my underscore func, or whatever you want your function name to be, but with the words separated out with an underscore. And then if you want a parameter, you can have something that looks like this, param1. If you want a default value for it, you can say equals to, and then input some default value. Then you can put in a colon here, and you see now we have an indented block, and anything inside of this belongs to the function. It belongs to the scope of that function. And then I can say something like print my first Python function. We will save this. Note that if I run the script, we shouldn't expect anything to happen, which nothing does happen because I've only defined the function. If I actually want to call it later on in my code, I say my func close parentheses. And here we have my first Python function. Great. If I wanted to use the parameter there, I could have also said something like .format, param1, save it, and then let's include that over here. Save that, run this, and we see, whoops, forgot to actually call it, my func, rerun. And here it says my first Python function and then default, whatever the default value for that parameter was. If we want our function to have a doc string, and that's just a documentation string, you type a set of 3 quotes, usually they're double quotes, but it can work for single quotes as well, and then another set, and then anything inside here, this is the doc string. So you probably noticed, as we were typing in methods and functions, if we ever saw the help here, len for instance, which was the length function, you get a little output here that says it returns the number of items of a sequence or a collection. Now, we might be wondering, how do I actually get that information? How do I know what this function does? Well, that is the doc string. So now let's try it with our own function. Going to save this, and then let's say my underscore func. You should notice now this is the doc string displaying here. And Python basically will go over to the function, check if there's a doc string immediately below as a multi-line comment, and you can do a multi-line comment with these sets of 3 quotes, meaning anything inside these sets of 3 quotes is part of the comment. So now again, if I check my func here, I see this is the doc string and then these various lines that I wrote. So keep that in mind. It's always good to document your functions, especially if you're going to be using them a lot, or especially if someone else is going to be reading your code. It's just the right thing to do. Now let's quickly go over the difference between printing something in the function and the return keyword of a function. So let's make a quick example, a classic hello function, and then we'll say print, and it just prints hello. We save that. If we want to call it, if we want to call it later on in our code, all we have to do is make sure you're lined up outside of the scope of the function. Call hello. We'll save this, run this code, and here I have hello. So again, indentation is very important. Make sure you didn't accidentally do something like this while you're coding. Now, that's the first example. Let's go on to example 2, which will, instead of just printing the hello, it's going to return hello. So we'll get rid of these parentheses and just say return the string hello. So now if I call hello and I run this, I don't get anything out. And that's because it was just returning hello. It wasn't actually printing it. So I can say something like result is equal to hello being called, and then I can print out that result. We'll save this, run the code, and now I see I get hello as the output. And this is the way you're going to see most functions work. it will actually return an object for you to save as a variable and use later on. Now, a quick note, again, if you're coming to Python from a different language that is not dynamic programming, you may have to be careful when you're defining a function as far as what inputs you expect. So let's imagine I create a function that adds two numbers together, and hopefully this example looks a little familiar to you. And it takes in num1, num2, colon, and then it returns num1 plus num2. What you probably expect your user to do is something like this. Result is equal to add num, and then let's say 2 and 3. And then if I print out my results, save it, we run this, and I get 5. But Python will work for a lot of things. So if I actually input two strings here, or let's say even worse, for some reason my inputs were strings instead of being numbers, we can save that, run this, and now it outputs 23 instead of 5. So this is kind of a more realistic error you might get in your code. Let's say you asked for a form input with Django and it returned it back as a string and you were expecting a number. This kind of error could easily occur. So what you may want to do is actually check for types. And you can check for a Python type using the type keyword. So if you say something like print type of result, I will save this. Let's run it. I get its class str, which means it's part of the string class. And then if I make these back into integers, save this and run this again, I get class int. So sometimes you'll probably want to have a check that says something like this. If type of num1 is equal to type of num2 is equal to type of 10, and then we'll have the colon here, return num1 plus num2. And then we'll say else, return, sorry, I need integers. So now let's see how this works. If I save this and run just print results, save that, clear my console, run Python notes, I get 5 out. But now if I type in 2 and 3, save that, run this, it says, sorry, I need integers. Again, this is a very simple way to test if type inputs are correct. We'll discuss much more formal methods such as checking for actual exceptions and errors and doing unit testing later on in the course. For right now, just keep this in mind that you may get different types than you expected, and that Python can still deal with them. Now let's briefly discuss what is known as a lambda expression. And often you won't always need a full-blown function like we've defined here. You may just want to use a function just one time, which means you didn't really need to define it more than that one time you used it. And in some of these cases, it makes more sense to use what is known as a lambda expression. And it looks like this. Lambda expression. So to actually get the full idea of when we would use a lambda expression, we need to use or introduce a function that accepts other functions as input parameters. So in this case, we'll introduce the filter function. So let's start by introducing how the filter function works, what it would look like with a normal function as accepted as the input, and then what it would look like with lambda accepted as the input. So I will create my list and set it equal to 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to create a function called evenBool. And let's do it in camel or snake casing. It accepts a number, and then it says return num mod 2 equal to 0. So what does that actually mean? It means it's going to return true if the number is even, or false if the number is odd. And then let's show you how you can use the filter function. The filter function takes in two arguments, and we can see them down here. It takes in a function and then a sequence. And what it does, it returns those items of sequence for which the function item is true. If the function is none, then it just returns the items that are true. So let's try this. I'm going to first pass in my function, which was even bool, and then I'm going to pass in my sequence, which is my list. And let's save this as a result called evens, and then print out evens casted as a list. We will save this, clear the console, and then run python.notes.py. And then here I have 2, 4, 6, 8. So I have now all the even numbers from this list. And this is again just filtering out wherever even bool returned true on my list. And then we had to cast it as a list, because if we didn't, we would otherwise get a little generator object. So if I save that and run this again, I get this thing that says filter object, and that's because, like I mentioned for range, this is actually a generator, and it won't actually create the list unless you specifically ask it to. All right, so now let's show you how we can do that with a lambda expression. So a lambda expression is basically a breakdown of this function, or of any function really. So let's break down this function into a lambda expression, and a lambda expression is pretty much always on one line. So the first thing we need to do is take care of the input. So a lambda expression has no name, which is why it's also sometimes called an anonymous function. So I replace all that with just lambda num. So again, I replace def, the name of the function, and any inputs with just lambda, and then the input itself. And then we say colon, we get rid of this return keyword, and now we have our lambda expression. This is the lambda expression version of the even bool function we just made. So I will cut that out and then paste it here. And this is a typical use case for lambda. We don't actually want to define an entire function if we were only going to use it once inside of another function. And now let's actually run this, and we see that it works the same way. And if we cast this as a list, before we run this, add in a parentheses here, run it again, you can see here now I have 2, 4, 6, 8. Great, so that is all working the same as it did before. So those are lambda expressions. We'll see them later on in the course, so if you don't fully understand them yet, don't worry, we'll get plenty of more practice with them. Finally, I want to show you just some useful methods that you may not be familiar with for all these various basic data types that we've learned about. So for a string, some nice methods that we've already discussed are .lower, which lowercases everything, .upper, which uppercases everything, and then split, which splits up on whatever you want to be a list. So let me show you a more realistic example of where you may encounter .split. Let's say we're trying to make a Twitter clone. So I say tweet, and I say go sports, hashtag sports. And I'm only looking for things that are on the hashtag. If I know there's only one hashtag somewhere in the actual tweet, then I can say split on hashtag. And later on we'll have an entire section on regular expressions, which are going to allow us to do much better searching through text than what I'm showing here. But let's do that. Let's say st.split, and I'm going to save this as result. And now let's run python.notes.py, and whoops, this should be not st.split, this should be tweet_split. Save it, now run it again. And we don't get anything back because I didn't print out the result. Save it, run it, and here it says go sports, sports. So I know sports here is the actual hashtag. So if I wanted just that, what was under the hashtag, then I could say 1 there, and I get out sports. And that's a way you would probably more realistically use the .split method off of a string. Then I want to quickly mention the in operator. It's not a method, it's just something that's really useful. If you ever want to know if something is in a sequence, for example, if I want to know is X in the list 1, 2, 3, all you have to do is use the keyword in to solve that. And this will return a Boolean. So I can print out the result of this entire thing, run the code, and it says false. X is not in 1, 2, 3. But now if I add X to this, save it, run it again, I get back true. Okay, there are a lot more examples of functions and various other things in the actual lecture notes, so check out part 8_functions.py for fully commented code with a lot more examples if you feel like you need more. Thanks everyone, and I'll see you at the next lecture.